Okay, so this is problem 12.5.45, and they're telling us here that the mean clotting time of blood is 7.45 seconds with a standard deviation of 3.6 seconds. And they want to know what's the probability that an individual's clotting time will be less than 4 seconds or greater than 13 seconds. And you have to pardon whatever I got on my paper here. I'm not exactly sure what I got on that. Okay, so to start this problem, let's just give ourselves a picture to be able to see what it is that we're talking about. So we have a mean of 7.45, and this is seconds. I'm going to leave the units off for now. And then they're asking us to find the clotting time that'll be less than 4 seconds. So I'm going to put 4 right there, and I'm going to shade what it is that we're actually looking for. So we're looking for this area right here, which is less than 4 seconds. And then it says that we're greater than 13 seconds. So here's 13 seconds, and greater than 13 is going to be all of that. Okay. So really what we need to do is we need to find this area and then this area, and we're going to find them separately, and then we're just going to add them together, and that's going to give us the answer that they're looking for. Okay, so so we're going to be working with this formula. Z is equal to x minus mu over the standard deviation. And these are particular x's, these the 4 and the 13. Our mu right here, standard deviation, or excuse me, our mean is the 7.45, and our standard deviation is given to us as the 3.6. Okay, so so let's go ahead and calculate the z-scores that are occurring at each of the 4 and the 13, and then we're going to need to think about what the z-score is actually giving us. Okay, so let's see, I'll put this, we'll come back to this. And I need more paper. Okay, that'll work. All right, so for x equals 4, let's go ahead and calculate the z-score. So we're going to have a z of 4 minus the 7.45, and then over the standard deviation of 3.6. Okay, so I'm actually using this formula and plugging 4 in for the x, 7.45 in for mu, and then the standard deviation of 3.6. So if you calculate this, just do this on your calculator, you're going to get z equals negative 0.96. Okay, now the chart in our book, which is on page 671, only gives the positive z-scores. So if you're dealing with a negative z-score, you're actually going to have to think about what that means. So let me show you what I mean here. So if I were to look on the chart on page 671, and I was to look at a z of a positive 0.96, that would actually be giving me this area right here. Okay, and I'm going to go ahead and look on the chart, and I would show you the chart, but it doesn't come through on this camera, so you're just going to have to look it up. So let's see, I'm looking for a z of 0.96, and that's an area of 0.331. Okay. All right, so with a z of 0.96, then we're looking at this area of 0.331. If we want to know what the z-score is, or excuse me, if we have a z-score of a negative 0.96 then, and that's associated with my x equals 4, then that tells me that if I want to find this area right here, because this area will correspond to 0.331, I'm going to have to subtract it from 0.5. Okay, so this area right here then is going to be 0.5 minus the 0.331. Okay, so that's going to be an area of 0.169. Okay, so if we go back to our original chart here with x equals 4, this area right here is going to be 0.169. Okay, so we found that one. And And let's go ahead and find x equals 13 now. So the z-score for x equals 13, we're going to plug the 13 in for the x. And you're going to get out a z-score here of 1.54. That's positive, so we can just use the z-score that we come up with on the chart. So if I look at 1.54, it's giving me an area of 0.438. Okay, now again, we have to think about what that's giving us because we're not actually just looking for that. So if we have, you know, let me actually go back to the chart here. So if I have my 7.45 and here's my 13, this area of 0.438 is actually referring to this area right here. So that's between the x equals 13 and the 7.45. Okay, but on our picture, we actually want this area that's to the right here. So again, we're going to have to subtract the 0.438 from 0.5, and that's because half of the values are going to occur above the mean, half are occurring below the mean. That's why I also used 0.5 up here. So this area right here is going to be 0.5 minus 0.438. Okay, and you'll get 0.062 on that one. Okay, so that's this area right here, 0.062. So to actually answer their question then, we need to add those two together. It's going to be 0.062 plus 0.169, and you come up with 0.231 will be your answer there. Okay, so in these problems, it's really important that you draw out these pictures for yourselves because otherwise, you know, it's kind of difficult to see what's going on in terms of what the z-score that you're getting. What is it referring to? Is it referring to what you're actually looking for? Is it referring to another portion of the chart? And this is why it's really important, you know, start with a picture that's identifying the areas that you're trying to find. And then as you're finding z-scores, you need to identify what is this z-score actually giving me, and then do I need to adjust it, you know, to find the region that I need by subtracting from 0.5, kind of a thing. Okay, so we had to actually do that on both ends here. So it's really important to be able to interpret, you know, what the z-score, what the chart is giving you in terms of area. Okay, and the pictures are going to be what's going to help you to do that.